Good afternoon. Welcome to the AIAA ARD seminar series. My name is Liz Ward. I'd like to see by show of hands, how many of you guys are AIAA members, either here or at your school? Put them way up, put them way up. Okay, I gotta count. Ben, you count for me. You're tall, stand up, count all these hands. Keep your hands up, guys. We are very privileged today to have, I think, one of the best female engineers that I've ever met with us, who's now a program lead for an agency program called Game Changing Technology Development Program. Her name is Beth Wusk, and I've invited her husband to introduce her. Mike Wusk works in the Aero. Well, actually, he works in the hangar, but he's with the Research Services Directorate. Come on up, Mike, come on. There's a couple seats up here, and there's two right in the middle if anybody needs a chair. Here you go, sir.
All right, thanks.
Thank you.
Okay, I was a little surprised when Liz called me to do this introduction, so hopefully I don't embarrass Mary Beth here too much. But your speaker today is a strong and motivated woman who could probably boast of a lot of accomplishments. She currently serves as the acting program manager for the Game Changing Technology Development Office, and as such helps to lead the development of over 50 up-and-coming space technologies. She's been involved in a wide variety of projects through her 27 years here at Langley, everything from aircraft auto lands, making air travel safer, to orbital rocket launches, providing satellites that help understand global climate change. From high-temperature material development that will one day enable Mars re-entries, to the present-day earthly application of that technology to help save wildland firefighters. Through it all, she's applied her technical understanding and her energetic approach to everything she's undertaken. But if you ask her, I think, what brings her the most satisfaction in her job, she will undoubtedly tell you that it's the opportunity that she gets to provide to interns and students. Well, I lost myself here. And she's going to talk to you about those experiences, but as a way of introduction, I want to say that I think she's truly a professional inspiration to a lot of people and a great friend to many. Like many women in today's work environment, she's done very well in a world that was traditionally, and not that long ago, strictly a man's world. She's endured a lot of those struggles and frustrations, but she's not only persevered and excelled in her own achievements, but she's always been willing to offer a helping hand to those coming behind her and following her lead. And some of those efforts or opportunities have included the creation of multiple STEM-based summer camps for underprivileged youth, implementation of several technical challenges for college competitions, and always the numerous interns and younger students. So she does these things because she knows the importance of getting the younger generation inspired to understand and lead this technical world that we live in. But whether she sees it or not, I see the real product of her efforts being the motivation and the inspiration that she gives the younger people. And through all that, from a young, energetic country girl to a Longwood University volleyball player, from an Old Dominion electrical engineering student to a NASA intern. She has worked her way up from a young instrumentation engineer to the program manager that she is now. And through that, she's expertly balanced her career with the demands of being an incredible mother of 3, now college-age kids, a daughter to an elderly mother, and most importantly, an absolutely wonderful wife and a partner to one lucky nerd engineer. But more importantly today, she's your guest speaker, so please welcome Mary Beth Wusk.
So nice to meet you. Okay, let's see. Did I turn it on? Okay. Wow, I didn't know Mike was going to introduce me. Him, and he just didn't say anything, so thank you for the introduction. That was very sweet. 27 years ago, I was in the same seats you guys were in. Actually, not in this building. We were in a different building. This is a really nice new facility for us here at Langley. I was a Langley Aerospace Research Summer Scholar. Very excited to be at NASA. I was nervous. I didn't know anybody. I don't know how many of you guys, how many people came, didn't know anybody else that was coming here. Yeah, it's a big step, but it's an exciting one. And I met some of the people that I met here during that summer. I'm still really good friends with. Actually, I married one. And it was just a great opportunity for me to get my foot in the door. And I hope that you guys take this opportunity to just sign up for everything. I'm glad you're here for the AIAA talk. If maybe you're IEEE, that's okay too. We let those people in as well. But just get involved. Liz is offering you guys a great opportunity to network, to see what we do here at Langley, and to just make connections. And it's up to you guys to take advantage of that. And I did it 27 years ago. I got a job offer right after I had finished my physics degree, and I was still working on my EE. And I got a job offer. I was like, wow, I could have a real paycheck and not live in my apartment where everything would fit in my car. So I was very excited about working out here, and I finished my EE after I started working full time. So it's a great opportunity, and I hope you guys get an opportunity to take advantage of all that. So what I'm going to tell you about today is some technologies that we work on. So as Mike said, I started out as an aircraft instrumentation engineer, and then I switched to the space side of the house. And it was a personal decision for me because we were both in the aircraft side of the house going on deployments, and I started having a couple kids, and that wasn't really working out. Us both going on deployment at the same time. So I switched to the space side of the house and started working. I worked on Calypso, which is an Earth observing satellite, and I did the ground systems and the mission operations for that program. And then I moved on to working on some research sounding rockets and also some small launch vehicles. So I've had an opportunity to work in many different areas across the center. And this program that I'm working on now is a kind of a culmination of all of the work. It's looking at all the different space technologies. I'm removed a little bit more from the aero side right now, but I'm focusing on what does it take to make our space technology feasible? How are we going to really get to Mars? What are those long poles, and how are we going to address them? Okay. Did I do that? Oh, you did that. You said keep moving. Okay. All right. So I got 40 minutes, right? All right. 35 or so. Okay, so space technology portfolio. I'm not sure how many of you guys are familiar with the Space Technology Mission Directorate, but we are, our budget is somewhere around $650 million per year, annual budget. And within the Space Technology Mission Directorate, there are 9 different programs. And starting from the left and kind of moving to the right, the left are lower technology readiness level. It's more operational concept kind of activities that are going on. You have the innovative advanced concepts. You have the grants and the fellowships that maybe some of you guys are involved with. And then you also have center innovation funds where each different center, sometimes they get some funding and they can it's like an incubator for some of their technologies. So once those technologies start building up a little steam, they come into our portfolio, and we're at the bottom in the middle. We're called the Game Changing Development Program Office. We have representation across all 10 centers. So we're an agency level office. We're located here at Langley. We're about $120 million annual budget. We got about 260 or so full-time equivalent people. That means that if everybody's working full-time, that's how many people we'd have. But nobody, people are specialists in different areas, so they cover different programs. So it's quite a few people across the agency. Okay, this sounds a little different. Okay, I guess that's good. All right, and then also you have you graduate from our program. We're the proving grounds. We're going to see, is this technology really something that's going to take off, or is it something that it was a good idea but it's just not feasible? So we are what they call technology readiness level 3 to 6. So an operational concept 1 to 3, or 3 to 6, and then if you want to be a big flight project, you're usually like 7 or 8 and beyond. And that's where we have the technology demonstration missions. We also have a sister organization called Small Spacecraft that does also flight tests and flight opportunities, which is really working with the universities and for commercialization of launch vehicles. A big part of what we have in STMD, Space Technology Mission Directorate, and I'll try not to use too many acronyms, is SBIR's, I did it anyway, Small Business Innovation Research. We have about a few $100 million where we invest in small businesses, and they get a technology call that we're looking for responses for, and that feeds into that area. So not to say that we're the center of the universe, but I kind of feel like we are. We're all of the bottom, the SBIRs, the small businesses, the Center Innovation Funds, the grants, the fellowships. Those are feeding into our game-changing development program. And then we're then taking that technology, it's either going to work or it's not going to work, and then we push it out to industry, or we push it out to technology demonstration missions, et cetera. And this is just showing you on the left the TRL levels, the technology readiness level. Okay. I think I've covered all this. Just to give you an idea, Mike mentioned it earlier, we have almost about 50 different technologies just this year. And each one of these technologies lasts like 1 to 3 years. So we have some moving in, some moving out. You get a different president, he may have different ideas on what you should be focusing on. So there's a lot of turnover in our technologies. I'm going to show you a snapshot of where we are today. All right, I'm going to show a brief video about GCD.
GCD is short for Game Changing Development. It's our program. Our goal is to discover new technologies, to enable new missions or make the current missions even better. We look at high risk, high payoff activities, and we look for changing the way a thing is done or made, and what does it take to get from the bench top or the lab to ready for orbit testing. And that's our niche.
Game Changing takes the technologies that have been worked on at the centers or in universities or by small businesses and takes them to the point where they could be infused into a NASA mission.
That looks at the lower level technology levels and takes on a little bit of a riskier portfolio in order to develop technologies.
I think Game Changer is not really afraid to fail, but they'd rather go after the failure to actually achieve something innovative and game-changing.
We get scolded if we don't have, failures. So I think, the fact that we're allowed to fail and learn from our mistakes is pretty unique.
We have a lot of technology first, and we mean no kidding, this has never been done before. One example is carbon nanotubes. We took that technology and made it into a nanowire and broke a record 3 times on how fast the electrical conductivity went through that wire. We were excited to be the first ones ever to put a 3D printer in space, and that 3D printer is on station right now, it's fully operational. And then we came into what was interesting, we needed some tool, and it happened to be a simple wrench, and they designed the CAD file down on Earth, shot it up there, the astronaut was able to push the button, and it printed that 3D wrench and was mission accomplished. I mean, that's the kind of thing that we're trying to do. Another example would be Robonaut.
So we really are focusing on tasks with Robonaut that can save crew time. Our astronauts tend to be our best and brightest, and they're really best used to be doing science.
We're looking at different technologies right now for spacesuits. Okay, we have a carbon dioxide and moisture removal system that goes in the backpack of the suit to remove, in a regenerative way, carbon dioxide and moisture from the suit. It really simplifies the suit systems. We're working on a glove. We're working on a pressure system, a pressure control system that allows a lot more capability for the suit. So we're working to enable human exploration.
The neat thing about this job that I find, one of my favorite parts, is the spin-offs that are associated with it. So now taking this technology and figuring out how we can use it to improve life here on Earth as well. One of the projects that we're spinning off of high ed technology is developing these fire shelters for firefighters.
We're testing thermal protection materials that were originally developed for use on an inflatable decelerator that will take humans to Mars or robots to another planet, and we're testing that for use as a fire tent to protect our firefighters. The current fire tents can't take a flame-on situation, and this material will help protect them against that, so we're really excited about that.
We're developing exoskeleton technology, which is robotics technology, and we're targeting our application for crew health. It can be used as a crew exercise device. It could also be used to improve crew efficiency and performance on orbit. But it also has terrestrial applications and benefits, such as, for example, people with disabilities, to help them with their mobility as well. The folks that develop these technologies are extremely passionate and enthusiastic about what it is that they do. And I think that's the thing that I enjoy the most. And I don't know what it is that we're developing in the broad portfolio, but something that we're developing is going to be included in one of these NASA future exploration missions, whether it be to Mars or Europa or any other planetary body, or even the discovery of a far-off planetary body. And I think that's what's most exciting.
We're working on some of the hardest problems, and you're pooling the best talent in the entire world, and you're trying to work together to work on these problems that you don't even know if there is a solution, but you're trying to see if you can get through that together. And I think that's the coolest part about it.
I really enjoy the technology. I guess I'm kind of a technology nerd in the sense that I think these things are exciting to see the developments and where we've come. What used to be on TV as a futuristic thing and now it's every common day. I think that's exciting to see, and I'm looking forward to what the next generation will bring.
Game changing is focusing on disruptive technologies that really will change the way we do something or create a new mission. And it's difficult, but if we accomplish it, it'll be a new rocket, it'll be a new propulsion system, it'll be a new life support system, it'll reduce the mass by half, it'll cut costs by 2/3. That captures what GCD is all about.
I still get excited when I watch that video. So that was just a brief snapshot of some of the team that's working on the project with us. So like I said, we have 50 different technologies, and this is not, my husband, when he's on this chart, he's like, that's too many words. But I just want to give you an idea. These are all the names of our projects, and we have quite a few of them. We have about 50 going on right now, and the different colors represent different areas. We do work in lightweight materials and advanced manufacturing. We do work in advanced entry, descent, and landing. We do work in propulsion systems and space power. Advanced life support and ISRU, and robotics and autonomy. So we kind of group them together when we're trying to tell our story to people. But what's another thing that's important here is, like I was saying earlier, technologies rotate in and out. We have 25 of our 50 that are rotating out this year. So this is a really active year for us. It's very exciting and nerve-wracking at the same time. We've been launching quite a few different technologies in the last couple months and getting those results in and seeing, are we going on to the next step or are we going back to the drawing board? Next slide. Oh, it's me. No. Okay. So in Space Technology Mission Directory, we have different strategic thrusts, and this is how we try to tell our story to people outside of SDMD and GCD. We want to utilize the near Earth space. We want to get to low Earth orbit, and we want to use that as a stepping stone to go beyond. So we have technologies in this area. We also then want to transfer through space efficiently and safely. We also want to, once we get there, we want to be able to enter the atmospheres and increase access to the various planets. So using the atmosphere to land safely as well. Then once you get there, we want to be able to use the resources. I mean, I love the movie Martian, and there are a lot of cool things in there. I do have to say, I went to a class the other day, and this little boy came up to me and he says, I just want an honest answer. And he says, I'm okay with whatever the answer might be. I don't know if I told you this. And I said, okay, what's the question? And he said, can you grow potatoes just in poop? Well, there may be some other resources you might need as well. But he said, okay, I just really appreciate somebody telling me because I've heard it both ways. So, but anyway, I think the movie The Martian really did impact people and understood thinking, wow, this could be real. And we're addressing what are the issues once we get there and how we're going to live. And then we want to look beyond that. How can we go beyond and look at, look at exoplanets and navigation beyond GPS, that sort of thing as well. And then lastly, we can't do this alone. Our budgets are shrinking. We need to have effective communications and partnerships with industry, with academia, and we're using it more and more as we go through. Okay, so I'm going to touch a little bit briefly on each one of these. I did this just for the first one. So each one of those topics, you dig down to the next level, and you're going to start seeing, okay, so for us to use the near Earth space, what does that really mean? And I want to maybe satellite propellant transfer and advanced robotics, and how are we going to make these vehicles lighter and stronger, and once we get there, how are we going to assemble them in space, and those sorts of things. So we want to have affordable access to space, and we want to be able to reuse our assets where we can. And then we want to use it as a stepping stone to go beyond. Next slide. So on the left, so now you see the same picture on the right, and what you just saw there. On the left, you see 9 of our projects. So I'm going to kind of briefly touch on, I don't know, not quite all 50 of them, because I don't have that much time, but different technologies and how we're supporting these efforts. And just to let you know, in the back of this presentation, which I will give to Liz once, now that I've just made those last-minute changes a couple minutes before the presentation, so you guys can have a copy of this, because there's information in there. If you want to learn more about each one of these technologies, we have fact sheets that are on our website, and I'll show you how to get to those. We have an app that if you have a NASA badge, we can give you access to, so you have it on your fingertips when you just happen, not being able to sleep and you want to look up what an Astrobee is. And then also the points of contacts in our organization. If you have an idea on a technology that could support one of the areas that we're working towards, who do you contact and how do you get that idea rolling? All right, so here I'm just showing 9 different technologies on near Earth space, and the first one is Astrobee. Astrobee is like a little drone that flies around the space station pretty much, and it's doing operations it's supposed to offload the astronauts. There's something called Spheres. I don't know if anybody's heard of it. It's currently being used on board right now. So this is the replacement for that. And we actually are launching, I think it is in March of 2018. It was supposed to be December, but slipping out a little bit on SpaceX 14. And we'll be checking that out. So this has been a project that's been going for about 3 years, and we're on the steps of sending it up to the space station. The next one is just the advanced cryogenic propellant tanks. This is where, I don't know if you guys have seen Isaac, if you haven't had a tour of the Isaac facility. It lays the composites. It's pretty cool. If you haven't seen it, you need to get to the fab shop and get a tour of that. Anyway, this is another opportunity of how things get into our pipeline. We have what we call announcements of opportunity. And I'm missing the C, collaborative opportunity. And so we have about 7 of those, or again, we're working closely with industry to get engaged. They bring a resource, we bring a resource, we work together to make a better product. Affordable vehicle avionics, this is an idea where we're using off-the-shelf commercial components and to use it for avionics systems. And the problem is, they're pretty expensive. Normally, avionics systems can range from $2 to $5 million, and when you're trying to do just a quick and dirty flight, that's hard to do. So these are running about $30K. We're launching our first one September 12th. September 12th, and it's actively going to be controlling an up aerospace launch vehicle. So that's coming up. Iodine Hall thruster. This is where we're looking at using iodine rather than xenon to have compress the density of the fuel, so you don't have to carry as big tanks with you. So we're working that. And the deployable composite boom. And some of you guys may be working on these projects. The ones that have an asterisk on them down at the bottom, they're the ones at Langley. The other ones are at the other centers. But so you may, somebody may have been working with deployable composite boom. They're trying to make, again, large arrays and deployable composite booms going up to about 14 meters. I think it's over in 1148. If you haven't had a chance to see it, that might be kind of a cool thing to do as well. Mixed reality crew assistance. This one I thought was kind of neat. This is being done out of JPL. And we're going to show the video real quick. So the concept is that you're augmenting what the astronaut is seeing. The idea is that, you know, he has a headset on, he's getting directions from a ground site, or he's also getting CAD drawings of what he's looking at and maybe directions on how to repair the instrument. So it's like being able to see inside that black box without really physically seeing in. I'm not allowed to go fast forward on videos, am I? Okay. I'm very patient. Okay. Nanotechnology, we just launched, I think it was in May, out at Wallops Island. If you haven't had a chance to get out there, some of my students went out there for a camp. Are they here today by the chance? Any chance of my students here? All right, you get a star. Where's the rest of the gang? Okay, all right, you're good. You're all good. All right. So anyway, we launched a composite overwrap pressure vessel with nano tubes, carbon nanotubes, and the idea is that this material, it has this 200 times the strength of steel and 5 times the elasticity. And it wasn't really in the exact application that we want it to be, but we wanted it to be it was actively controlling the vehicle as part of the attitude control system. And it worked great. I think they did have a little problem with their vehicle on the landing. The parachute didn't quite work the way expected, but we got our data, and we got the COPV back. And the data looked extremely, extremely good. So it was the first time it was flown in a structural environment. Things went well with that. We have tech ad sets, 6 or 7. They have quite a few. This is another project out of Ames where we're ejecting payloads off of the space station, and we're trying to see how we can control the reentry without having any thrusters by using a drag chute. And then we have some tipping points. Again, this working with industry. I better hurry. All right, so then once we take off and we got lighter and stronger and our systems, our ground systems are operating, we got to get through space, and this is really our future propulsion and energy systems. So ideas here, we need to have advanced thermal management. So we have that first phase change material heat exchanger that's currently flying on space station now, where we're using wax to help with the thermal active control. This is actually going to be used this is one of our infusions that are actually going forward to Orion. And the high capacity cryocooler, this is for, again, thermal management for cryogenic fuels. And just in this unit alone, I didn't realize this, there's 16 miles of this tubing that is in there. So we're in the process of verifying that works. We're also looking at using that for our nuclear thermal propulsion system as well. NTP, nuclear, this is a big area for us right now. Like I said, our budget's about 120 million. This is about 19, 20 million just this year. So rather than be explaining nuclear thermal propulsion, which I probably wouldn't do a very good job, I thought I'd show you a quick video.
First-generation nuclear thermal propulsion, or NTP, could enable both faster transit between the Earth and Mars and a series of advanced space missions. Nuclear thermal propulsion is powered by nuclear fission, which has been used on Earth for more than 70 years. How it works is conceptually simple. Energy from fission is used to heat hydrogen to about 4,400 degrees Fahrenheit. This hydrogen is then accelerated through a nozzle, resulting in a propellant efficiency roughly twice that of the best chemical rocket engines. Nuclear thermal propulsion was considered for use in the Apollo program, and significant development and ground testing was accomplished. Advances in technology since the 1960s may improve its affordability, viability, and acceptability. For example, it may be possible to fuel modern NTP systems with low-enriched uranium instead of highly enriched uranium. In addition, it may now be possible to ground test NTP systems at established, safe, self-contained rocket engine test facilities. For human Mars missions, the physical size of an NTP engine is largely determined by the rate at which fission energy can be transferred to the hydrogen propellant. However, the equivalent volume of the uranium that would be split is actually quite small, roughly that of a toy marble. That energy is used to get astronauts to Mars faster. NTP can take months off the trip compared to using traditional chemical systems, reducing risks associated with exposure to galactic cosmic radiation, microgravity, and other hazards of deep space travel. The maturation of nuclear thermal propulsion will also facilitate the development of fission surface power systems, enabling a power-rich environment at any exploration location. Abundant power could also be used for in-situ resource utilization, life support, communication, and other diverse applications. First-generation NTP systems are a first step towards advanced nuclear propulsion systems capable of travel throughout the solar system.
So just to jump ahead a little bit, one thing that's really cool in this project is I get to go see all this technology. And one of the things that, it wasn't NTP, that's being done down at Marshall with BWXT and Dynetics. And we're looking at using Stennis for their facility for testing. I mean, it's going to be down the road a little bit. But we also are working very closely with the Department of Energy. And I got to go out to the Nevada test site. I was a little nervous because they put me in boots and I didn't have a canary, but I did have a Geiger counter on and oxygen measurements, and they took me 1,000 feet underground and it was dark. I'm a little claustrophobic. We got down there and we got to see their testing facility where they do a lot of the nuclear testing. We are doing the first nuclear test, not with the nuclear thermal propulsion, but our project called Kilopower. And we're doing a test with highly enriched uranium. This is low enriched uranium. And we're going to be doing that. I think the test is going to be finishing up in January. So the team's working really hard to move forward on that as well. So exciting stuff, and you get to see some really cool things. Just a couple other things on here. We also focus on advanced manufacturing techniques, and we're looking at additive manufacturing. We work with Marshall, and also here at Langley, we had to build these engines is very expensive. So if we can you can cut the development time down by half on these motors. So we've been building low-cost upper stage engines that are made out of copper, and then there's a external wrapper of Inconel, which gives you the copper handles the heat but doesn't keep its shape well. The Inconel does that for you, and that was done here at Langley as well. So I should have had an asterisk on that as well. Advanced near net shape. This is an idea where you're actually spinning material over a mandrel and it's shaping it, and you're putting in these different cylinders. So you don't have all these bolts, and it's more one piece. This was developed actually out of Germany company who builds clutch motor housings for cars. And the team just went over there last week, and they were working on that. They built a 10-foot diameter unit. They built 4 of them, actually, 4 or 7, and different heights, and looking at the fabrication process. So things are going well there. We also do a lot of testing. We do a lot of hot fire testing as well for different engines that are being developed by companies. All right, next slide. Okay, so then once we get through space, we want to land. And this is an area that I spent quite a bit of my time in my project careers on hypersonic inflatable aerodynamic decelerators. And this was a project that I guess I'll show you a quick video. All of these are looking at different ways to handle entering an atmosphere. And as you know, when we're landing on a planet, you want to use any resource that you can. You only have a heat shield that can be so big based on the shroud of the vehicle, right? So we want to extend beyond that, and that's how we deal with these inflatables. There's multiple different approaches on this, and we're looking at what is the best combination of technologies. The next one is more of like an umbrella. It has some structural as well as some soft goods as well, and that's depth. And then propulsion descent technology. This is where you have the motors and you're slowing yourself down as you begin to land, and we're working very closely with SpaceX on that. So different, and there's several different other technologies, but why don't we go ahead and show them the high-end one. This is the launch that we did. It was actually in 2012 when I was project manager of this effort. We had an RV2, and then we did an RV3. And we wanted to launch a vehicle, re-enter the atmosphere, and experience the high heat rates and ensure that the materials could handle it, both the structure and then the thermal blanket above, over it. A lot of time out at Wallops. We actually put these little kids glow-in-the-dark stars, in the video. They weren't mission assurance approved. This is the cameras looking in, so this is animated, right? Same sequence going on. Nitrogen tank on board, and we inflated it. And that was just from materials that were captured inside, and then we started inflating it to that green ring, and that gave us the structure that we needed before we entered the atmosphere. So all those calculations on how long it would be exo-atmospheric and how quickly do we have to fill. There's a lot of ground tests that went to make sure that the sheet, the center of gravity, so we could just see if we can learn how to control it just by shifting the weight during the flight. That was part of the experiment as well. We had a lot of temperature, pressure measurements on the nose cone, and then also embedded within the structure itself. To be in the control room and see Earth was really cool. To see our payload coming in, it was on the big screens, and it was pretty impressive experience. So from that, we're now working with ULA. We're also working with Global ATK and looking at recovering launch assets, and also ISS down mass using inflatables as well. So that was a really cool project. I had a great time doing it. The team worked hard because we had come off of a failure. I mean, that was IRVI 3. IRVI 2 was not as challenging of a heating environment. We did that, no problem. But IRVI 1, the pyros were wired backwards, and the payload got jammed into the launch vehicle, and then it just went to the water. So, I mean, you have to check everything when you do a flight, and it's very nerve-wracking when you sit in that control room and you're thinking, oh God, did I do everything I possibly could on the ground to make sure this is going to work? And both IRVI 2 and IRVI 3 flights went flawlessly. So from that experience, I guess I don't have too much more time, so I'll try to hit the high points. I was watching the news, and there was fires, and just like there are now, they're like crazy right now going on. And there was a fire in Prescott, Arizona, which there is one, I heard on the news yesterday, again, where 19 firefighters got caught in a fire, and they used these entrapment shelters. And I was sitting and watching it with my husband, I was like, and I saw their entrapment shelters, and it just looks like a tinfoil wrapper. And which it kind of is, because it's good for radiating the temperature, the heat off, but it wasn't good for convective heating. And these 19 firefighters got caught in the fires, and since their shelters could not handle the direct flames, they all died. And I talked to my materials expert on the team, and I said, hey, is there anything we can do? We just spent how many years on this thermal blanket, and we've been doing arc jet testing, and we've been doing, we've launched, and we know the materials well, but that's kind of a thick blanket that we had on there. We didn't have to worry about weight. And I said, is there anything we can do to potentially make this a safer environment? And we got in touch with the Forest Service, and then I'll let the video tell the story.
We're circling overhead. We do have a few patients we were trying to reach in Yarnell.
Yarnell Hill, Arizona, 2013. There were 19 firefighters that were battling a wildfire. They can't get away from the fire to their safe zone, meaning their safety route's been cut off. They have to deploy their shelters.
They knew that they had fire on both sides of them. They had fire behind them, and now they have fire ahead of them.
These shelters are only brought out when there's no other way out. So the firefighters will encapsulate themselves in it as the fire blows over.
Did they deploy, they said?
Yeah. We're talking minutes when they made this decision. And they were in a very tight deployment area. All of their shelters were pulled, and they all deployed at the same time, and they all died in this location.
We took note of a tragic loss of firefighters in the summer of 2013, and we thought if there is something that we're doing inside of NASA that can be worked in a little bit of a different way and have a bigger application out in the commercial world, we look at that opportunity.
We take this technology that we've been developing for a space application and transition it to support the needs of these entrapment shelters.
NASA's been working on a technology that is going to be enabling humans on Mars for exploration, and that's the inflatable decelerator. One of the key engineering requirements for that decelerator is to have a flexible thermal protection system.
There's a lot of common themes here between the flexible heat shield material that we work with here at NASA and the fire shelter.
All right, well, let me just tell you how that story ends. So we are actually in our I think we started in really hardcore 2016, and it's now 2017, and we're working with the Forest Service. I took total advantage of people like you. I had a team of 5 interns, and I made them test my team made them test like 200 different layups You might have been part of it, I don't know, but thank you. And we looked at different materials, and I'm not saying we're using the same materials that we use for space, but the whole concept of how we approached it is clear to a path to go forward. And we're working with the Forest Service. We've tested. I sent a couple of my interns up to, oh gosh, I can't remember what's called, Northwest Territories in Canada. They had to wear these big bug suits because the flies and everything were just crazy. That's why we sent them. And it was a full, they burned a whole lot, a lot of like trees maybe in the size of this room. It was controlled burn with the Forest Service there. And we had our shelters in. And so we wanted to see how, because you can get different results when you use propane in a lab and then versus when you're using, when you're, have the natural burning. And we're making really good progress. Each time, this thing had to be less than 5 pounds, had to pack into like a milk carton. So you might have really good ideas, but, and we had a lot of companies call and say, oh, our material worked great. Well, it's like, a huge blanket. These guys don't want to carry that on their backs. They have to carry these all the time. So we came up with a great concept, went really well, and then they said the odor from the gas barrier was too strong. So back to the drawing board. And then we said, okay, well, let's make it a different shape. Let's make it, if I'm in a fire, I'm all about being in the fetal position and praying. But they want to be laid out. And so we're looking at less surface area, right? So no, we had to go back to the drawing board. You couldn't go with more of a pod type thing. So we're working with them very closely. We're making really good progress. We're looking at intumescent materials that kind of expand. I don't know if any of you guys, you're probably way too young for this, but remember when you used to have these little snake pellets at 4th of July and you light them and they expand. So it's the same kind of concept to give you that additional insulation. So anyway, we're working with the team. We're going to be doing another round test. We've gone up to Canada multiple times. That's where their testing facility is, whether it's in the lab or also in the forest. And we're probably going to do another test in Idaho come September or so. So I don't know if it's going to, if our product will be the one that will be selected, but I know we're making a difference, and that's where I like to see all of this technology go. So the next one I was going to show you is how we go beyond and how we do some of the science activities that are beyond, for exoplanets. And we're looking at coronagraphs, which are looking, to masking off the stars and then seeing if we can see exoplanets. We're looking at, making progress. Various other technologies as well. And we're also doing a lot of teaming. You can just go towards the end. I think I'm pretty close because I think I wanted to let them have a couple of questions. All right. And in the slide presentation, you'll see, you can just skip down past that. Keep going. It's like a million meg file now with all my videos in it. So, all right, and we do a lot with robotics, and then also actually developing structures, using regolith and different materials available to you, rover technologies, anything that helps survivability once you're on the planet. Let's go to the next slide. And then, like I said, now we're looking at extreme environments. We need to make gears that don't have to have a lubricant, so they can handle these really cold temperatures. Or else we need the batteries to be able to work in cold temperatures and electronics. So we're working hard for those types of things. So for if we're going to Europa, icy moons of Jupiter. Next slide. And again, this is just gives you an idea of we're not doing this alone. We're working with partners to make this happen with us. So we have a lot of partnerships that we're working now. These are just some of the highlights that are coming up. Sextant actually launched, and they are actually deployed, and we should be getting our results. That's the project that's looking, they like to call themselves the Galactic Positioning System. They're using the neutron stars to do the navigation rather than GPS. So it's a GPS satellite. So that's being deployed, and we're going to find out. It just launched. I was supposed to go to it, but I didn't go. June 30th. No, I'm sorry. June 1st, the end of the month, beginning of the next. And so they're checking that out. And like I said, the kilopower That's where we're going to be doing the testing out in Nevada, and several other launches that we're checking out, the avionic systems and the reentry vehicle. Next slide. One thing I just wanted to bring up before my time runs out, which is really important to me. Mike did say that I'm big into students. Well, I am, because I was one, and I know how important having a good experience as a student is. It can either turn you on to being an engineer, or say, no, I'm never going to do that. That was awful. So I really like the idea of having competitions, and I don't want to waste anyone's time. I'm like the queen of stealing people's resources, and so we've done multiple test campaigns where we had an idea, a concept. The first one was we wanted to see who could help us control an inflatable to re-enter the atmosphere. You know, I showed you how we did the center of gravity shift. So we put that concept out there. We had 17 universities respond, and the University of Illinois Champaign won. And what you get to come. We had 4 universities that we narrowed down to. They came out here for 2 days, did a presentation, met lots of people, did a lot of networking, and then the winning team got an internship. They had a great time. They were here the last day of the internship. Their badges were about to expire, and they're there at 6 o'clock at night trying to finish their designs. And then we have this year, our competition was installing spacecraft. And so my University of Maryland team is here. My Tulane team is at Ames. So we gave 10, I think it was about 10 internships for students to then come here and build your ideas. And we're about to release, I don't know what it is yet, so we're still figuring it out. We have a meeting this week, our competition for next year. So please be on the lookout for that. All right, next slide. Everything I've told you, there's a lot of information, a lot of different projects. It's all on our website, so you're welcome to go check that out. And next slide. And we also have this mobile app. We won't have time to do a demo. So it's a really cool app. You can pull up, like I said, any of the projects, and you can see, you know, kind of where we are with our technology, what TRL level it's at, what their goals are, that sort of thing as well. So very informative. I use it for my management team, so we all are on the same page on where we are, and it's automatically updated through the cloud. So we're maintaining configuration control on that. Next slide. I think that might be close to the end. Oh, one more thing. I said I wanted to give you the contacts. I mean, I'm a contact, but these are the ladies and gentlemen who are leading the different technologies in the different areas. So they're called our principal technologists. So if you have ideas that you want to go forward with, talk to them. They're all very easy to communicate with. Their information's here for you. So there are 9 of them. It shows you the different areas that they focus on. Okay, I think, is that the last slide? Okay. So hopefully you understand a little bit more about GCD, about what we do, where we're going, why we're doing it, and also how to get involved with GCD if you're interested. I have a few minutes for questions. Is Elizabeth here? Yeah. Go ahead. Well, here at Langley, we use them. The Chiefs effort that we're working on for the fire shelters, we went to them when we said, hey, we kind of have this concept for a terrestrial application. How do we go about it? And they started working with us on the patent process. We put patents in through them. They're helping us do commercialization. So we met actually just last week with a company that wants to now commercialize the product, maybe not just for the Chiefs, not just for the fire shelters, but there's a lot of things that need high temperature insulation. So they help us navigate through that process. Good question. Yeah. Oh, that's another good question. So obviously, you know, we get guidance from headquarters, and you're looking at how does it play into our mission objectives, right? And then a lot of times it's political. Sometimes you have, you know, earmarks that, you know, you need to, Congress says, hey, we want you to focus in this area. And so we do some of that as well. We also look for partnerships with companies, and, you know, because we're much stronger together than we are alone. And also looking at what the centers bring and what makes sense for, you know, each center has kind of a different flavor of what they're focused on. For us, for GCD, Langley is really known for entry, descent, and landing. All right, well, hey, I appreciate your time. This is hard to do after lunch, so I appreciate your attention. And I hope you have a great summer. And if there's anything I can do to help, please let me know. Thank you.